this is the 7.3 homework. I am going to do this a little differently. Just due to lack of time, I'm just going to give you some examples how to do these. A lot of it can be done with your calculator, so if you have your calculator out while you're doing this video, it's going to help you out a lot because that's mainly what you're going to be using for this homework set. Alright, so in this section you're going to be doing a lot of matrix operations, meaning you're going to be adding, multiplying, subtracting, that kind of thing. So in your calculator, the matrix menu is the second menu of the X inverse button. So I mean I can hit second X inverse and I can come in here to the matrix menu and create these matrices. So it's telling me that matrix A, I'm going to go over here and edit. Matrix A is a 3 by 3, meaning there's 3 rows with 3 numbers in each row. Alright, 3 rows, 3 columns. Alright, and then just start putting in the numbers. So we got -6, -10. Alright, so I've got matrix A completely filled in with all the numbers that they gave me in this problem. Hit second quit, make sure you back out, go back to the home screen, come back in, and then go into matrix B, go to the editor, come down to matrix B. Alright, matrix B in this case is also a 3 by 3, so tell it 3 by 3. Alright, and then put those numbers in. Alright, and then there is matrix B completed. Alright, second quit again, second mode to go back to the home screen, come back into the matrix menu to call matrix A plus, because we got a plus sign in between these two. Alright, and then go back in and call matrix B. Alright, hit enter, and then there's our answer. So 1, -15, -28. Alright, and then there's our answer. A plus B gave me this. I've got it all in there. I'm going to check the answer. It says, hooray, you did it right. Alright, now notice, yeah, you can do it with your calculator, and that's fine if you can do it with your calculator, but when it's adding A plus B, you just add the corresponding values. -6 plus 7 is 1. -10 plus -5 is -15. -13 plus -15 is -28. So A plus B, if it's just basically that, it's almost easier, it is easier just to look at it and do it. Alright, for something like this, I want you to do 2B. Alright, so A is not being used here at all. Again, you can go into the matrix menu, you can go down here and edit matrix B. Alright, this is a 2 rows, 3 in each row, so this is a 2 by 3 this time. Alright, and if you get those backwards, 3 and 2, 2 and 3, just this one has 3 things to fill on the top, 3 on the bottom. If you did a 3 by 2, it's going to have 2, 2, and 2, and that's not what this looks like. So if you get those backwards, just look at it before you start filling in blindly and realize that you've made a mistake on it. So just look before you start automatically typing numbers in. Alright, and after you've got it in, always get out of here, because you can put a matrix in a matrix, and you don't want to do that here. Okay, now 2B, just literally write 2B, 2, and then go back into the matrix menu to call your matrix. 2B, and there's our numbers: 620, -2, 4, -10. And again, it is as simple as doubling everything in B. 6, 2, 0, -2, 4, -10. So again, it's another one with scalar multiplication like this. You can really just do it by looking at it. Alright, and then this may be where you want to start using your calculator, where you have to do the scalar multiplication on each one of them and then combine them together. So if that's the case, then maybe quicker to go to your calculator and help you. So stick them all in there. All right, both of these are 2 by 2s. I've already got matrix A and B in there. And then just write what you see. Negative 3A. Go in here, matrix A. Okay. Minus 3, and then go back in second matrix. Option 2 is B. Alright, and there's our answer. Alright, put that in. Checks. Well done. Alright, go to the next one. Alright, on this next one, if it's possible, multiply these. A times B and B times A. Now, when you're multiplying matrices, I'm going to give you an example over here. When I'm multiplying a matrix by another matrix, so I'm going to put in A, B, C, D, E, F, G, H, I. Alright, I'm multiplying that times another matrix. J, K, L, M, N, O, P, Q, R. Now when I do this, this very first position here, what we call the 1-1 position, meaning the first row, first column, the way I get this is I multiply this row times this column, component wise, meaning A gets multiplied by J, B gets multiplied by M, C gets multiplied by P. But when after I multiply those components, the row times the column, I add them together. So the way this works, after I've multiply, I get A times J plus B times M plus C times P. Alright, and all of that ends up being just this first position here. Okay, all that ends up being the first position. Alright, I kind of ran out of room here, so I had to delete that other piece. But for the second position, we do A times B times C times the middle row. Alright, and that's going to give us the number that goes in the middle of the top row. So that would be A times K plus B times N plus C times Q. Alright, and then if we want to do the last thing on the top row, I'm completely out of room there because it's got a lot of computation to compute these elements. It'd be A, B, C multiplied by LOR. Okay. Now when I move down, if I want to get the numbers on the next row, it would be D, E, F times these 3 columns to get me those 3 elements, and then G, H, I times these 3 columns to get the bottom row. Okay. Now the way it works, if you multiply a M by N matrix, if you multiply that by a N times, I'm going to use Q matrix, I'm going to skip O and P, what you end up with is these inner terms basically kind of wipe out, and then it just kind of squeezes together. Alright, that's what I say. I mean, it's because of the way we do multiplication, but you end up with an M by Q matrix. Okay, now for the problem we're doing, we have a 3 by 3 times a 3 by 3. So if we go back over here, a 3 by 3 matrix multiplied by a 3 by 3 matrix. Alright, these inner numbers here wipe each other out, and we end up with a 3 by 3 matrix. Okay, but you know, if we had a 4 by 6 times a 6 by 2, we'd end up with a 4 by 2. Right, a 3 by 2 times a 2 by 5, we end up with a 3 by 5. Okay. We'll get to more of that with more examples that we do. Now, I'm not going to require you show me all this work. I will allow you to do it on your calculator again, since we're running out of time this semester. Alright, but I just wanted to show you how matrix multiplication works. Alright, so store these two things into your calculator. Okay, there's what your matrix A should look like. So if you want to pause it and verify that you're getting the same thing I am. Alright, and then there is your matrix B. Alright, now, the first thing we want to do is A times B. So, go back to your matrix menu. There's A. Go back in again. There's B. You don't have to put the multiplication symbol between the two. Okay, now if you did, I'm going to go back and call the last thing we just did. I'm going to squeeze in the times symbol. Okay, and notice what we have right now, 10, negative 14, 9. If you put the times symbol in there, you're going to get the same thing. Okay, so with or without the times symbol, it's still going to give you the same thing, but we're multiplying them here, so if you wanted to put the multiplication star, it's fine. Alright, but there's our answer. Alright, there's our answer, and again we see it works. Alright, now, second part, B times A. Two things I want you to see here. One, go back to your second matrix menu, this time call B first, right, and then go back and call A. The big thing I want you to see is it's not the same thing. A times B and B times A are completely different. Okay, the commutative property that we get in numbers, like 3 times 2 is 6, 2 times 3 is 6, it doesn't jive for matrices. A times B and B times A are completely different things, matrix multiplication. So multiplying on the left, multiplying on the right are different in matrices. That's the other thing I wanted you to understand. When we do problems in the last couple sections in this chapter, sometimes I'll say things like multiply on the left, multiply on the right, and it matters. You got to make sure that you put your matrix in the proper order, or the matrices that you're multiplying in the proper order, because of that non-commutative property that they have. Alright, this is a question 7 in your homework. This is what I was talking about before. If we have A times B, A is a 4 by 5, B is a 5 by 1. So that's what we were talking about before. 4 by 5 multiplied by 5 by 1. Again, as long as these inner numbers are identical, you can do the multiplication. If these are ever different, you can't do it. But since these are the same, the 5s are the same, we're going to end up with a 4 by 1. So those outer parts come inside and they become the new matrix dimension. Alright, now B times C. 5 by 1, 1 by 4, so we get a 5 by 4. Again, the 1s are the same on the inside, so we can do the multiplication. And we just get those two outer things. Now A times C. A is a 4 by 5, C is a 1 by 4. Okay, 5 and the 1 this time don't jive, so we can't do that multiplication. Alright, we have two matrices. They want us to find AB and BA if it's possible. Alright, so first of all, this first matrix is a 3 rows, 2 columns. So the first one is a 3 by 2. And what are we multiplying it by? We're multiplying it by 2 rows, 3 columns. We're multiplying by a 2 by 3. Alright, those are going to wipe each other out. We get a 3 by 3. So it is possible, and they're giving us a 3 by 3 down here. Okay. Now, part 2, when we do B times A, B is a 2 by 3, and we're going to be multiplying that by a 3 by 2. So that also is going to be possible, and we're going to end up with a 2 by 2. Okay. Alright, now again, two ways you can do this. I don't care if you do it with your calculator. So go in and put the matrices in. Alright, there's what your matrix A should look like. So pause it and verify yours looks that way. Alright, and there's what your matrix B should look like. Alright, so again, all I want you to do is learn how to do this. Just go through, rewatch these videos as much as you need to be able to do it without eventually looking at the videos. So A times B is that. So I'm going to put all that in. Alright, there's our matrix. It says good job, so we know that that's right. Now the other way I wanted you to see is, remember, this negative 15 comes from 0 times negative 4 plus negative 3 times 5. So there's the negative 15. This negative 6 comes from 0 times negative 2 plus negative 3 times 2. Okay, this 0 here comes from 0 times 3 plus negative 3 times 0. Alright, this 3 comes from 3 times negative 4 plus 3 times 5. There's the 3. This 0 right here comes from this 3 times negative 2, which is negative 6, plus 3 times positive 2, or times positive 2, which is positive 6. And they cancel each other out to 0. 3 times 3 is 9, plus 3 times 0 is 0. 9 plus 0 is 9. Okay. Negative 2 times negative 4 is positive 8, and then negative 4 times positive 5 is negative 20. 8 plus negative 20, negative 12. So again, you can do it by hand. It's fine with me though if you go ahead and do it on your calculator. Alright, now B times A, just again, make sure you get it in that right order. B has to come first, and then A. So negative 12, negative 6. 6, negative 9. Alright, word problem. So this table, both of these two tables, one gives exports, one gives imports. So they want us to complete parts A through E from the matrix A that contains a number of millions of dollars of exports in 2000 and 2006. So basically it's just saying put these numbers in these columns. Alright, so we put them all in there, and that's all it's wanting. Okay, it's just wanting us to form the matrix of imports, or sorry, exports. Alright, then part B wants us to do the imports. So again, just these two columns. So I've got those two columns in there, assuming I can put them in right. Now, write the matrix C. C is A minus B. Alright, so I've put matrix A and B in here. Now notice when you put matrix B in, I wanted to bring this up because this number here is so large, it's more than 6 digits, it puts it in scientific notation, but notice that it does leave it right down here. It just displays it in scientific notation in the matrix. That's fine. Anytime that you get 7 digits or higher, it's going to display scientific notation. So don't worry about that. It does have it stored the right way though. Alright, so C equals B minus A, or sorry, A minus B, A minus matrix B. So there's our numbers, our answers. Now you can hit left and right on a matrix that it returns as the answer if there's large numbers in there, and sometimes there'll be decimals in there, but you can always scroll left and right to get as many place values as you need. Alright, and then there's our C matrix that we got from our A minus B. Now again, word problems, you want to make sure that you understand what it is your answers mean. So in what categories and years does the country have a positive trade balance? Alright, positive trade balance means you exported more than you imported. So if you exported more than you imported, then A minus B would be positive. So here and here were the only two that were positive. Alright, so in agricultural, in both 2000 and 2006 was the top. Okay, so again, I'm just looking at the top here. That corresponds to the top here, the two positive values. So those are agricultural. Alright, which category was the trade deficit the greatest? That's the biggest negative number that we see. So that would have to be this negative 334,275, where that big 1 million number came from. Alright, so that would be in manufactured goods in 2006. Okay, and then why is this trade deficit the greatest? This is the most negative entry. Now, this is used a lot in business. Matrices are used a lot, but you would see someone do something like this in Excel. Right? They're not calling them matrices. They're calling them, you know, sales in Excel. But it's basically what you're doing is you're grabbing the data, you know, from a table, possibly in Excel, and you're doing these matrix operations on them. You could easily do them as matrices, and technically Excel is treat them like matrices. Alright, so in this problem we're wanting to take these median annual incomes from 1999 and determine the matrices. The median annual income increased by 12%. Alright, so these incomes went up by 12%. We want to come up with what that new median income would be. So an increase by 12% means we multiply by 1.12. Okay, 1.12 because the 1, meaning which stayed the same, the 0.12, 12% of all these values, and 1.12 is 1 plus 0.12, meaning we took the original values and we added the 12%. So take 1.12. Alright, we stored that one. I stored it as matrix A. Alright, there's two 3x2s, but I know I stored that as matrix A. Hit enter. Alright, and then there's our value. They want an integer or decimal. So there's the decimals that go in, and again that's correct. So again, all I did, if you look at it, is I stored, there's matrix A. I just stored all those values that were in there, and then I multiplied that matrix by 1.12, which multiplies every single value. It multiplies 39,339 by 1.12. Okay. Every single component in that matrix gets multiplied by the 1.12 when we multiply a matrix by a scalar. So that's where all these numbers are coming from. Alright, and then this last problem. So this is our breakdown, our demographics. So if you look at what this information is telling us, the T, the R, the P, the T stands for television, the R stands for radio, the P stands for papers. Okay, so this is how much was spent on singles. This is how many ads per month. These three media are targeted to single people, to married people. So this is, they're doing 32 ads, 46 ads, 36 ads. Okay, a TV ad costs $10, a radio ad costs $17, $4 for newspaper ads. Right? They want total cost. Well, how do you determine total costs? So if they ran 32 television ads at $10 each, how do I compute that? Well, that's obviously 32 times 10. Alright, plus I ran 46 radio ads at $17 each. So 46 radio ads at $17 each, plus 36 paper ads at $4 each, and that gives me 1,246 that we spent for singles. Alright, same thing I can do for males. 27 times 10. Plus 30 times 17. Plus 41 times 4. Alright, 944. Alright, and the same thing on the bottom. Alright, and then there I get 949. I don't know where that 27 is coming from. 949. So there's my answer. Now, what I also want to show you is that's no different than if I filled out these as matrices. Matrices, that is. There's matrix A. Quit, come back in, edit matrix B. Right, so there's matrix B, a 3 by 3. Now, what did we do? Look back at all those multiplications that I did. I did 32 times 10 plus 46 times 17 plus 36 times 4. I multiplied this row times this column. So I'm multiplying B times A. So if I just take matrix B times matrix A, what do I get? Those same three things. Okay, so all I'm doing is just multiplying B times A here. Now notice that if I screwed up and I did A times B, what's happening? My calculator is telling me dimension mismatch. That's what's going to happen if you can't do the multiplication. So it's important, again, this is what I was talking about, you've got to make sure that you do it in the correct order. Why didn't this work? Because matrix A is a 3 by 1, matrix B is a 3 by 3. 1 and 3 aren't the same, so this wouldn't work. Okay, but B times A does work because it's a 3 by 3. This is a 3 by 1, and that 3 and that 3 are the same. So we end up with a 3 by 1 as our answer. Okay, so just make sure that you can see that this is just multiplication. That's all you're doing here. You're multiplying matrix B times matrix A to get this total cost. The way we multiply matrices is the way we compute total cost in this case. The number of ads times the cost of an ad is the total cost for that type of ad. But the overall total cost is the overall cost for this type plus the overall cost for this type plus the overall cost for this type. And if you think about it, that's matrix multiplication right there.